Hello, my dear students. I am Professor G.N. Rajappa. HOD, Professor and HOD of Mathematics, AIT, Chikmagalur. So now I am going to start Unit 6, Laplace Transforms. Definition. If f of t is a real valued function for all t greater than or equal to 0, the Laplace transform of f of t is usually denoted by L of f of t and is defined as L of f of t is equal to integral from 0 to infinity e to the power of minus st f of t dt, that is equal to f of s. S is parameter, it may be real or complex. That means L of f of t equal to f of s equal to integral from 0 to infinity e to the power of minus st f of t dt. This is the definition. S is parameter, it may be real or complex. By using this definition, so we are going to prove some standard results. Number one, prove that L of A is equal to A by S. Prove that L of A is equal to A by S. So now by using the definition, we know L of f of t equal to integral from 0 to infinity e to the power of minus st f of t dt. This is the definition. So by using this definition, we are going to prove L of A is equal to A by S. In place of f of t, write A. That means therefore L of A is equal to integral from 0 to infinity e to the power of minus st into A into dt. So we want here L of A. So in place of f of t, write A. That means L of A is equal to integral from 0 to infinity e to the power of minus st into A into dt. A is constant, we can take outside. The remaining is integral from 0 to infinity e to the power of minus st into dt. We know integral of e to the power of ax dx is e to the power of ax by a, like that here. So that is equal to a into e to the power of minus st by minus es from 0 to infinity. Integral of e to the power of ax dx is e to the power of ax by a. Put a is equal to minus es. Now you put t is equal to upper limit infinity. So infinity into s is infinity with negative sign is there. So that means that is equal to minus a by s into e to the power of minus infinity minus. Put t is equal to 0. 0 into s is 0. E to the power of 0 is 1. That means that is equal to minus a by s into it. We know e to the power of minus infinity equal to 0. E to the power of 0 is 1. That means this is here 0 minus 1, that is equal to a by s. That means L of A is equal to A by S. For example, here L of 1 is equal to, put A is equal to 1, we get L of 1 is equal to 1 by S. So when A is equal to 1, so L of 1 is equal to 1 by S. Same time, L of 2 is equal to, here if you put A is equal to 2, we get L of 2 equal to 2 by S. Put A is equal to 3, you will get L of 3 equal to 3 by S, like that here. Next, number 2, prove that L of e to the power of 80 is equal to, prove that L of e to the power of 80 is equal to 1 by S minus A. So S greater than A. S greater than A. Same type proof here. Proof. By definition, first you write the definition. L of f of t equal to integral from 0 to infinity e to the power of minus st f of t dt. By using this definition, easily we can prove L of e to the power of at is equal to 1 by s minus a. So we want L of e to the power of at. So in place of f of t, you write e to the power of at. So then here L of e to the power of at is equal to integral from 0 to infinity e to the power of minus st into e to the power of at dt. That means in place of f of t, you write e to the power of at. So L of e to the power of at is integral from 0 to infinity e to the power of minus st e to the power of at dt. That is equal to integral from 0 to infinity e to the power of minus of s minus a into t into dt. Here e is same here by adding the powers. So minus st plus at equal to minus of s minus a into t. Otherwise you can write a minus s into t, but here it is s greater than a means you should write s minus a into t. Now again by using this formula here, integral of e to the power of ax dx equal to e to the power of ax by a. So now it is of the form integral of e to the power of a, this is a x into dx form, that is equal to, so e to the power of minus of s minus a into t by minus of s minus a from 0 to infinity. Now you put t is equal to infinity here. Infinity into s minus a is positive. S is greater than a means s minus a is positive. So this is positive and this is negative. So infinity. So infinity into positive into negative. That means that becomes here e to the power of minus infinity minus. Again put t is equal to lower limit 0. So 0 into s minus a is 0 e to the power of 0. E to the power of 0 divided by minus of s minus a. Again we know e to the power of minus infinity is 0. So e to the power of minus infinity is 0. E to the power of 0 is 1 by minus of s minus a. Here minus minus cancel, the remaining is here 1 by s minus a. So this is equal to 1 by s minus a. That means L of e to the power of at is equal to 1 by s minus a. For example, L of e to the power of 2t is equal to, for example here, put a is equal to 2. Put a is equal to 2, you will get 1 by s minus 2. This is the answer. So 1 by s minus 2. For one more example, L of e to the power of minus t. L of e to the power of minus t. Put a is equal to, by comparing these two here, it is of the form L of e to the power of at. A is minus 1. So put a is equal to minus 1 here. Then this becomes 1 by, so 1 by s minus of minus 1, that is equal to 1 by s plus 1. So L of e to the power of minus t is 1 by s plus 1. L of e to the power of 2t is 1 by s minus 2. L of e to the power of 8 is 1 by s minus a. And the previous result is L of a is equal to 1 by s. So L of a is a by s. This is number 1. Number 2, L of e to the power of at is equal to 1 by s minus a. L of e to the power of 8 is 1 by s minus Ca. Next, number 3, prove that L of sin hyperbolic 8 is equal to a by a square minus a square. So prove that L of sin hyperbolic 8 is equal to a by a square minus a square. The proof is very simple here, very easy. We know that sin hyperbolic theta is equal to e to the power of theta minus e to the power of minus theta by 2. We know sin hyperbolic theta is e to the power of theta minus e to the power of minus theta by 2. Here by comparing these two, this is sin hyperbolic theta form, put theta is equal to 80. Put theta is equal to 80, then this becomes here sin hyperbolic 80 is equal to e to the power of 80 minus e to the power of minus 80 divided by 2. This is sin hyperbolic 80. We want here L of sin hyperbolic 80. So taking Laplace transform both sides, we get L of sin hyperbolic 80 is equal to, so L of e to the power of 80 minus e to the power of minus 80 by 2. One by 2 is constant, we can take outside, that means this is 1 by 2 into L of e to the power of 80 minus L of e to the power of minus 80. L of e to the power of 80 minus L of e to the power of minus 80. That is equal to 1 by 2 into, we know L of e to the power of 80 here. L of e to the power of 80 is 1 by s minus Ca. So by using the previous result, 1 by s minus Ca minus, again we want L of e to the power of minus 80, replace A by minus A, in place of A write minus A, then that becomes 1 by s plus Ca. Here 1 by s minus of minus A is plus Ca, 1 by s plus Ca. Take LCM, that is 1 by 2 into, so LCM is s minus A into s plus A is LCM. Here this 1 into s plus A is s plus A minus s minus A. Here 1 into s plus A minus 1 into s minus A. Plus s and minus s cancelled here. A, this becomes minus into minus plus A plus A, 2A by, so this is 2A divided by 2 into A minus B into A plus B, using that formula here. A minus B into A plus B is A square minus B square. That means A square minus A square. 2 cancelled, that is equal to A by A square minus A square. So that means here L of sin hyperbolic 8 is equal to A by A square minus A square. That is number 3. So L of sin hyperbolic 8 is equal to, so A by A square minus A square. For example, here we want L of sin hyperbolic 2t. We want L of sin hyperbolic 2t. Put A is equal to 2. You will get here L of sin hyperbolic 2t is equal to, put A is equal to 2. So you will get here 2 by A square minus 2 square. So that means the answer is here 2 by A square minus 2 square. This is the answer. Or 2 by A square minus 4. One more example, L of sin hyperbolic t equal to By comparing these two here, put a is equal to 1. Put a is equal to 1. You will get 1 by a square minus 1 square. That is the answer. So 1 by a square minus 1 square. Next, number 4. Prove that L of cos hyperbolic at is equal to L of cos hyperbolic at is equal to s by a square minus a square. Prove that L of cos hyperbolic at is equal to s by a square minus a square. The proof is very simple again here. Proof, we know that cos hyperbolic theta is equal to cos hyperbolic theta is equal to e to the power of theta plus e to the power of minus theta by 2. And here we want cos hyperbolic at. So put theta is equal to at. So put theta is equal to at. Then this becomes cos hyperbolic at is equal to e to the power of at plus e to the power of minus at divided by 2. So in place of theta you write at. You will get e to the power of at plus e to the power of minus at by 2. Taking Laplace transform both sides, we get L of cos hyperbolic at is equal to, so L of e to the power of at plus e to the power of minus at divided by 2. That is equal to 1 by 2 is constant, we can take outside. The remaining is L of e to the power of at plus L of e to the power of minus at. Same here as it is, you write here 1 by 2 take outside. The remaining is L of e to the power of at plus this plus here L of e to the power of minus at. That is equal to 1 by 2 into, again by using the second result, we know L of e to the power of at is 1 by s minus a. Use that formula here. So 1 by s minus a plus, again in place of a write minus a. We get here L of e to the power of minus a is 1 by s minus of minus a. That is 1 by s plus a. Just replace a by minus a. Take LCM. That is equal to 1 by 2 into, so LCM is s minus a into s plus a is LCM. S minus a into s plus a. So this becomes 1 into s plus a plus 1 into s minus a. S plus a plus s minus a. Plus a minus a cancelled. That is equal to 1 by 2 into 2s divided by, here s plus s, 2s by a minus b into a plus b, by using that formula a square minus b square. That means here s square minus a square. So a square minus a square, that is 2 to cancelled. That is equal to s by a square minus a square. That means here L of cos hyperbolic at is equal to s by a square minus a square. That is number 4. So L of cos hyperbolic at is equal to, so s by a square minus a square. Next, number 5. Number 5. Prove that L of sin at is equal to a by a square plus a square. Prove that L of sin hyperbolic sin at is equal to a by a square plus a square. Proof. By definition, by definition, we know that L of f of t is equal to integral from 0 to infinity e to the power of minus st f of t dt. This is the definition. We want L of sin 80 means in place of f of t you write sin 80. Here also you write sin 80. So in place of f of t you write sin 80. Then that becomes L of sin 80 is equal to integral from 0 to infinity e to the power of minus st into sin 80 into dt. So in place of f of t, write sin 80. And now we have to integrate this one here. Clearly it is of the form integral of e to the power of ax sin bx dx form. By using that formula, so integral of e to the power of ax sin bx dx is equal to, so e to the power of ax into a sin bx minus b cos bx divided by a square plus b square. This is one of the standard formula. So integral of e to the power of ax sin bx dx equal to e to the power of ax into a sin bx minus b cos bx by a square plus b square. Now by comparing these two here, put a is equal to minus s and x equal to t and b is equal to a, you will get the answer. That means here replace a by minus s and b by a and x by t. So in place of a you write minus s, in place of b you write a, in place of x you write t. That means this is equal to here e to the power of minus st into minus s into sin 80 minus b into cos bx, b means a into sin a into cos 80 divided by minus s whole square plus a square from 0 to infinity. Here from 0 to infinity. Here by using that formula here, e to the power of ax into a sin bx minus b cos bx by a square plus b square. That is equal to, now you put t is equal to infinity here, upper limit infinity. So infinity into s is real number or complex, again that becomes infinity with negative. So e to the power of minus infinity is 0. So e to the power of minus infinity equal to 0. 0 into something here, that means here these two are always here lies in between, these values are lies in between minus 1 and plus 1. So that means 0 into something is here 0 minus, if you put t equal to lower limit 0, e to the power of 0 is 1 into minus s into sin 0 is 0 minus a into cos 0 is 1 divided by a square plus a square. So here minus s into 0 is 0, minus into minus plus, a into 1 is a into 1, again a by a square plus a square. So that means a divided by a square plus a square. So L of sin 80 is equal to, so L of sin 80 is a by a square plus a square. For example, L of sin 2t. For example, here L of sin 2t, put a is equal to 2, you will get 2 by a square plus 2 square. That is the answer. So 2 divided by a square plus 2 square. One more example, L of sin t. Here the coefficient of t is 1, here the coefficient of t is a, put a is equal to 1. In this formula put a is equal to 1, you will get the required answer. That means here 1 by, so 1 divided by a square plus 1 square. This is the answer. That means L of sin at is a by a square plus a square. So that is number 5. So L of sin at is equal to a by a square plus a square. Next, number 6. Prove that L of cos AT equal to S by a square plus a square. Prove that L of cos AT is equal to S by a square plus a square. Same procedure, same method. First you write the definition. In place of f of t, you write cos AT. So in place of f of t, you write cos AT. Here also write cos AT. Here we want L of cos AT, that means in place of f of t, write cos AT. Again, by using the standard formula, we know integral of e to the power of ax into cos bx dx equal to e to the power of ax into a cos bx plus b sin bx divided by a square plus b square. So that means here by comparing these two, put a is equal to, that means replace a by minus s, b by a and x by t. So in place of a, b, x, you write minus s, a, t respectively. So then this becomes here, this is equal to e to the power of minus s t into a cos bx. A means minus s into cos a t plus a sin a t divided by minus s whole square plus a square from 0 to infinity. So integral of e to the power of ax cos bx dx equal to e to the power of ax into a cos bx plus b sin bx divided by a square plus b square by using the formula. That is equal to, again if you put a is equal to infinity here, infinity into s is infinity with negative, so e to the power of minus infinity is 0, 0 into again something is here except infinity is 0, 0 by a square plus a square is also 0 minus, because here always sine and cosine, they are always lies in between minus 1 and plus 1, these two values in between minus 1 and plus 1. Next minus, if you put t is equal to lower limit 0 here, 0 into s is 0, e to the power of 0 is 1 minus s into cos 0 is 1 plus a into sin 0 is 0 divided by a square plus a square divided by a square plus a square. So after simplifying here, that means this is a into 0 is 0. Here minus into minus plus s into 1 is s by square plus a square. So s by a square plus a square. So L of cos at is equal to, here L of cos at is equal to s by a square plus a square. For example, L of cos 3t, for example L of cos 3t, put a is equal to 3 here, put a equal to 3, then this becomes s by a square plus 3 square. So s divided by a square plus 3 square, or s by a square plus 9. One more example, L of cos t, L of cos t, that means put a is equal to 1 by comparing these two. So put a equal to 1, then this becomes here s by a square plus 1 square or 1. So that means here L of cos AT is equal to number 6, L of cos AT is equal to, so S by A square plus A square, L of cos AT. Next, number 7, prove that number 7, prove that L of t to the power of n equal to n factorial divided by s to the power of n plus 1, where n is equal to 0, 1, 2, 3, 4, 5, etc. That means non-negative integer. So n is integer, positive integer including 0 also. So prove that L of t to the power of n is n factorial by s to the power of n plus 1. Proof. Important result this one. This is very important. By definition, we know L of f of t is equal to integral from 0 to infinity e to the power of minus st f of t dt. This is the definition. So by using this definition, we have to prove this result. By comparing these two here, put f of t is equal to t to the power of n. In place of f of t, write t to the power of n. Then this becomes here L of t to the power of n is equal to integral from 0 to infinity e to the power of minus st into t to the power of n dt. So in place of f of t, write t to the power of n. Now we have to integrate this one. We know integration by parts. So integration by parts is integral of uv dx equal to integration by parts. So first function u into integral of v dx minus integral of derivative of first, that means derivative of u is u dash or du by dx into integral of second, integral of v dx into dx. Here first function into integral of second minus integral of derivative of first into integral of second. This is called integration by parts. Now here this is u, first function, this is here u and this is v. So integration by parts. So that means t to the power of n, integral of v, that means integral of e to the power of minus st is e to the power of minus st by minus es from 0 to infinity. First function into integral of second minus integral of derivative of first. Derivative of t to the power of n is n t to the power of n minus 1. So derivative of t to the power of n is n into t to the power of n minus 1 into integral of e to the power of minus st is e to the power of minus st divided by minus es into dt. That is equal to, now you put t is equal to infinity here, e to the power of minus infinity is 0, that means 0 by minus es is 0, minus put t is equal to 0 here, then this becomes 0 into 1, that is 0 by minus s is also 0. Actually here if you put t is equal to infinity here, this becomes infinity into 0 form you will get. By applying L'Hospital's rule, that means as t tends to infinity, t to the power of n by e to the power of st, by applying L'Hospital's rule, that becomes here 0. Here 0 minus put t equal to 0, 0 into 1 is 0 by minus s is 0. Minus into this minus plus n by s you take outside, the remaining is 0 to infinity e to the power of minus st into t to the power of n minus 1 dt. Here minus into minus plus n by s into e to the power of minus st t to the power of n minus 1 dt. That is equal to, so n by s into, so L of t to the power of n is equal to, now you observe here, if it is t to the power of n, this is L of t to the power of n. If it is n, this is also n. Now here the integration is same, this is also same, and this is t to the power of n, but this is t to the power of n minus 1. By comparing these two here, this is n minus 1, that means this must be equal to here L of t to the power of n minus 1. If it is n minus 1, here also you should write n minus 1. That is L of t to the power of n minus 1. You call this as 1. Similarly, L of t to the power of n minus 1 is equal to, here next you find this value. L of t to the power of n minus 1, replace n by n minus 1. In place of n, you write n minus 1 here. In place of n. Then this becomes n minus 1 by s into L of t to the power of n minus 1 minus 1. N minus 1 minus 1 is n minus 2. N minus 2. Again next you write this value. L of t to the power of n minus 2 is equal to, so L of t to the power of minus t to the power of n minus 2 is equal to, in place of n you write n minus 2. Then this becomes n minus 2 by s into L of t to the power of n minus 2 minus 1 3, etc. So L of t to the power of n is equal to, left hand side is equal to, etc. Here at the end, here this is L of t to the power of n, next is L of t to the power of n minus 1, L of t to the power of n minus 2, etc. You find L of t square. Put n is equal to 2 here. L of t square equal to, put n equal to 2 by s into L of t to the power of 2 minus 1, that is t. 2 minus 1 is 1. Again you find this value here, L of t to the power of 1 is equal to, put n is equal to 1. L of t to the power of 1 is equal to 1 by s into, so 1 by s into L of t to the power of 1 minus 1, that becomes 0. So that means L of t is 1 by s into L of t to the power of 0. Now you substitute all the values here in this result, in 1. So L of t to the power of n is equal to n by s into L of t to the power of n minus 1. But L of t to the power of n minus 1 equal to this. That means n minus 1 by s into L of t to the power of n minus 2. But L of t to the power of n minus 2 equal to this here. That means n minus 2 by s into etc. etc. So L of t square equal to 2 by s into L of t to the power of 1. But L of t to the power of 1 is equal to 1 by s into, so into 1 by s into L of t to the power of 0. So L of t to the power of n equal to n by s into this, but this equal to this here, again this equal to write this here, etc. L of t square equal to this you write here, 2 by s into L of t, but L of t is 1 by s into L of t to the power of 0. That is equal to, so we know 1 into 2 into 3 etc. n minus 1 into n equal to n factorial. N factorial is n into n minus 1 etc. up to 3 to 1. And again we know a into a etc. a, if there are n times, that is equal to a to the power of n. Now here 1, 2, 3 etc. up to n is equal to n factorial divided by a into a etc. a, there are n times, that is equal to a to the power of n means s to the power of n into L of t to the power of 0 is 1. T to the power of 0 equal to 1. That is n factorial divided by s to the power of n into L of 1. From the first result put a is equal to 1, you will get 1 by s. So that means L of 1 is 1 by s, because so L of 1 is equal to 1 by s. That is, so that is equal to n factorial by s to the power of n plus 1. So L of t to the power of n is equal to. So L of t to the power of n is n factorial by s to the power of n plus 1. N is 0, 1, 2, 3, 4, 5 etc. like that here. For example, L of t to the power of 4. L of t to the power of 4. 4 is integer. So put n is equal to 4. You will get 4 factorial by s to the power of 4 plus 1. So 4 factorial by s to the power of 4 plus 1. This is the answer. Or you can write here 4 factorial is equal to 24 by s to the power of 5. This is the answer. Same type, one more example, L of t cube. So put n is equal to 3 in the standard formula. Put n is equal to 3. 3 factorial by s to the power of 3 plus 1. 3 factorial by s to the power of 3 plus 1. That is equal to 6 by s to the power of 4. 6 by s to the power of 4. So that means L of t to the power of n is n factorial by s to the power of n plus 1. So number 7, L of t to the power of n is equal to n factorial by s to the power of n plus 1. So n equal to 0, 1, 2, 3 etc. Next, number 8. Number 8. Prove that so L of t to the power of n equal to gamma n plus 1 divided by s to the power of n plus 1. This symbol is called gamma and this symbol is called beta. Beta and gamma function. So definition of gamma function. So gamma function. So definition is gamma function definition. So gamma function is defined as gamma n equal to integral from 0 to infinity. Gamma function is defined as, this is gamma here, the symbol is gamma. Gamma n equal to integral from 0 to infinity e to the power of minus x, x to the power of n minus 1 dx. So this is the definition of gamma function. Gamma n is integral from 0 to infinity e to the power of minus x, x to the power of n minus 1 dx. Now we have to prove L of t to the power of n is gamma n plus 1 by s to the power of n plus 1. The proof is very simple here, very easy. So proof, by definition L of t to the power of n is equal to integral from 0 to infinity e to the power of minus est into t to the power of n dt. So L of f of t equal to integral from 0 to infinity e to the power of minus est f of t dt. In place of f of t, you write e to the power of en. Now that is equal to here. You compare here these two. That means put est is equal to x. You will get the answer. So put s into t is equal to x. So put s t is equal to x. Then here differentiating we get s into dt is equal to dx. Therefore dt is equal to dx by es. Dt is equal to dx by es. And we have to change the limits also here. When t is equal to 0, x is 0. Here when t is 0, 0 into s is 0. X equal to 0. When t is equal to infinity, so x is equal to here infinity into s is also infinity. That means this becomes here 0 to infinity. Here x varies from 0 to infinity. E to the power of minus s into t is equal to here x into t, but t is equal to here. This implies here t is equal to x by s. So x by s to the power of n, same here n, into dt is equal to dx by s. So dt is equal to dx by s. Now s and n are constants because we are integrating with respect to x here. So you take s and n outside. That is here 1 by s to the power of n plus 1. Here s to the power of n into s is s to the power of n plus 1. Integral from 0 to infinity e to the power of minus x to the power of n dx. That is equal to 1 by s to the power of n plus 1. And again by using this definition, this is equal to gamma n plus 1. That is all. That means this is equal to here gamma n plus 1 by s to the power of n plus 1. So L of t to the power of n is equal to, here where n is constant you write here, where n is constant. Here this equal to here, replace n by, here replacing n by n plus 1. Then this becomes gamma n plus 1 is equal to 0 to infinity e to the power of minus x into x to the power of n dx. Now here these two are same, here these two are same, that is equal to gamma n plus 1. So this is L of t to the power of n.